Lagrange's linear PDE, right? So examination point of view, this is very, very important, but at the same time, it is very, very easy also, right? I hope all of you put your name and number in the chat box. If you're not, you kindly type your name and number in the chat box immediately. I think 11 people are there. 10 to 11 people are there. All of you type your name and number in the chat box, because I already told you, in all classes you have to do it, right? Okay, so now I share my screen. All of you type your name and number in the chat box immediately. Right, are you able to see my screen now?
Yes, sir.
Yes, sir.
Right, right. So my
Yes, sir.
audio and video is clear, both. Okay.
Yes, sir.
Okay, right. Thanks. So now we are going to see about Lagrange's linear equation. Lagrange's linear equation. So Lagrange's linear equation also a partial differential equation. It's also a partial differential equation of the form capital P into small p plus capital Q into small q equals to capital R. You know what is this small p and small r? Because small p and small r are already, you know, they are partial derivatives, right, with respect to x and y, right? Then what is this capital P and capital Q and capital R? They are all functions of x, y, z. They are all functions of x, y, z. So P may be x square plus y square, and Q may be y square plus z square, or maybe sine of x plus y. So this P, Q, R are all functions of x, y, z, and this small p and small q are derivatives, right? So in this Lagrange's linear equation, you can find all your x, y, z, p, and q. So everything is present. But one important thing is that P should present only one time, right? This small, right? It should be present only one time, and power also should be 1. Similarly, Q also should be present only one time, right? And the power of this also should be 1. So for a perfect example, I can show an example like this. So can you see this example 1 now? So it is there. So y square zx is a function of x. So we call this as our capital P. That is multiplied with small p. Then some x z is there. This is nothing but capital Q, right? And this is small q. And then right hand side, some function of x, y, z. So it is y square. So this is capital R. So whenever an equation, if this form where the first order partial derivatives occur only one time, that is very, very, but occur only one time, right? And it's also of power 1, right? It's also of power 1. Then there is a standard procedure is there to solve this problem, right? That procedure I will explain you, right? So by solving this, we will get a solution of this equation. That solution is nothing but the general solution of the PDE, right? So whenever we solve a Lagrange's equation through our standard methods, we will come to end of a general solution, not a complete solution, right? So first I will give the definition. So because here it is already visible, so if you want to take down, you can take down, or you can take a snapshot of this, you can take a snapshot of this, right? So whenever I give a thing, you can take a snapshot of this, right, in your phone, right? If your laptop is there, you can record it even. But if you have a mobile phone, you can take a snapshot of this, right, before writing. But I want you have to be write everything in a notebook, right? Only during class, right, writing may be difficult. You have to see here and you have to hear and then write, right? So then for that purpose, you can take snapshots. But when you come to the college, right, definitely you have to show me all your notebooks, right? So the definition says, right, what is Lagrange's linear equation or Lagrange's linear partial differential equation? Here they put equation, but it is not ordinary equation. It is a PDE. So you just follow me. A partial differential equation of the form PP plus QQ equals to R, where P, Q and R are functions of x1, y, z, and then small p and small q are dou z by dou x and dou z by dou y. That is the standard form of first order partial derivatives, right? Then this equation, this PDE, right, is called the standard form of first order partial differential equation, and this standard form of first order partial differential equation, right, is also called as Lagrange's linear equation. Just like in type 2 we have a Charpit's method, right, the equation of the form z equals to px plus qy plus function of p and q. The same way, whenever you can see PDE in the standard form like pp plus qq equals to r, then that first order PDE is called as Lagrange's linear equation. It's called Lagrange's linear equation. And I already teach you when we form the PDE for this type of equations, right? So whenever we have a equation with the unknown function, then form a PDE by eliminating arbitrary function. So that time we'll discuss this problem, and that time we end up with this type of PDE at the end, right? If you want to check, you can check one or two problems, right? Even in assignment also, I gave one problem like this. Those who already solved the assignments, they know I already gave one problem, right, in the assignment on this. Find how to find capital P and capital Q and capital R, and then finally write this as a PDE for this equation, right? So we already solved, even in the assignment itself, so given one problem, how to form a PDE from this equation, that is phi of u comma v, from this equation to this, right? Now we are going to do the reverse process. Now PDE is given, you have to solve it. When you solve, you will get a solution which is a general solution, because in that solution there is a arbitrary function is there, that is phi, right, with two arguments u and v, with two arguments u and v. So here the problem is you have to find these two arguments, what is u and v, what is u and what is v, right? For that there is a standard procedure is there, right? For that there is a standard procedure is there to find the who is coming now. Aman Kumar. Aman Kumar? Aman Kumar? Are you able to hear me? Aman Kumar? I don't know, I can't able to hear you, but whatever it may be, right? Okay, right, you have some audio problem, so that you are typing. See, class is at 12:20, right? 1 or 2 minutes, okay, but you, right? So hereafter you have to attend on time. Okay. So now I'll teach you, right, how to solve this PDE, which is of the form PP plus QQ equals to R. Right, so for that a standard working procedure, that is working rule is there, so that only I am showing now. So working rule to solve this PDE, right? First you have to write, so whenever you identified a PDE of this form, then you can solve that PDE by rewriting the PDE in this form, right? So how these equations are come, there is a procedure, there is a derivation is there, so that you no need now. So only thing is, whenever you find an equation of the form PP plus QQ equals to R, right, then your work is to solve these equations, right? So remember here, dx by p is nothing but this one, dy by q is nothing but this one, and dz by r. So you have to write, since the given PDE is the Lagrange's linear equation, right, the auxiliary equations of the given PDE, you write this, right? But how this comes, sir? So you don't worry, because there is a derivation is there. If you solve this auxiliary equation or substitutory equation or simultaneous differential equation, this is also called as simultaneous differential equations. If you solve this, you whatever the solution you are getting in the form of u and v, that you have to put like this, phi of u comma v, because phi of u comma v is your assumed solution, right? Is your assumed solution. When you solve this problem, definitely you will get a general solution. General solution must have a arbitrary function phi, and it has two arguments u and v. So when you solve the simultaneous equation, you will get u and v. then you can directly substitute the u and v here. Then this will be the solution of the given PDE. So here you are not going to solve directly the given PDE. You have to rewrite the PDE in auxiliary equation form. Then you solve this this called as equivalence, right? Because three things are equal, so they call as equivalence. And then if you solve this, you will get u and v. So at this junction, it looks difficult to you, but we will see one example. Then it will be a very easier one, and you can easily find U and V. And examination point of view also, these are very important, right? So we will see one example. Once the example, you understand the example, then everything will be in a clear manner, right? So are you able to see the example one now?
Yes, sir.
Right. So what is given here? It is given as y square z by x into p plus xz into q equals to y square, right? So when you look at the equation, you have to justify that it is in the form of Lagrange's. Two things you have to check: whether p and q are present. Yes. Whether it present only one time. Yes, it present only one time. What is the power of that? It is only one. Then what is associated of p? It is a function of x, y, z. Q, yes, it is also a function of x, y, z. On right hand side, yes, we have some function of x, y, z there. So this is Lagrange's equation that you have to write first. Once you write that thing, then you can take what is your p, what is your q, and what is your r. You have to identify p, q, and r, right? So these things you have to do it for all Lagrange's equations. Once you identify your p, q's, and r, you can directly write the subsidiary equation or simultaneous differential equations or auxiliary equations are all same, right? So you write dx by the p value, dy by the q value, dyz by the r value. Solving these equations is equivalent to solving the given PDE. But how to solve? How to solve? Try to remember, if three things are equivalent, right, you can equate like a by b equal to c by d equals to e by f, right, a by f. Then you can take any two of them and equate it, and you can find a solution, right? So here what you have to do is you have to take any two things, you can group any two things, and then you can try to solve it. Solve it means doing integration, because now we have dx and dy. So I already told you, right, given equation is a PDE. So there small p and small q are dou z by dou x and dou z by dou y. But now these auxiliary equations are not PDEs, they are ordinary differential equation. You can see here they use the symbol d, not dou, not dou, right? So these are ordinary differential equations. So what we need is, if you write a functions of x alone with the dx and functions of y alone with the dy, then automatically we can integrate it, right? Otherwise, when we integrate with the dx, only x terms should be there. When we integrate with the dy, only y terms will be there. Then only we can do the integration, right? So now here they are taking the first two things here, x dx, dx and dy. Since x in the denominator of denominator, they taken into the numerator. So it is written as x dx by y square z, and this is dy by xz, right? So out of three, you can equate any two. So I am taking now 1 and 2. You may ask, sir, why are you taking 1 and 2, not 1 and 3, right? So remember, here the procedure is only a random one. There is no systematic procedure is there, right? So once you write an auxiliary equation, somehow you have to solve using the relations, you have to solve. So it is only a trial and error method, right? So I am taking 1 and 2 first, right? So what is my intention? I need x terms with x dx and y terms with dy. So I don't want z terms, because there is no dz here when I take only 1 and 2. So here, fortunately, we can cancel z's on both sides. That is one thing. Another thing, fortunately, we can separate x and y with left hand side and right hand side. You see, this x goes this side, it becomes x square, right? And then this y square goes numerator, become y square. So x goes with x, it become x square, and this y square goes this side as y square. So now we have a nice function of x with the dx, function of y with the dy. Now you can integrate this. So when you integrate this, integral of x square is x cube by 3, integral of y square is y cube by 3, and whenever we do integration, we have to always put a integrating constant c. Right? So take this y cube on the other side and take the c on the other side, right? And finally you can write x cube minus y cube to 3c, but c is the arbitrary constant, 3c is also arbitrary constant, so we just name it as a, right? Just name it as a. Even if you name here a also, then your here will get 3a, no problem. If a is arbitrary, 3a is also arbitrary. So right hand side is some arbitrary constant is there, but the important thing is what is left hand side, right? X cube minus y cube. This x cube minus y cube, whatever we are getting from taking the first two terms, is nothing but a relation between x, y, z. So that is nothing but your u, right? So whatever you are getting x cube minus y cube by a, that is nothing but u. So now in place of x cube minus y cube, right, in place of u, you can substitute x cube minus y cube, and right hand side is a arbitrary constant, that is already a is there. So what is u? You found u is x cube minus y cube. But for finding the solution, you no need, you are not only you need, we also find v. So v is also a solution derived from this auxiliary equation. So now what we have to do, just like equating 1 and 2, we take the other two things, maybe 1 and 3 or 2 and 3. So here I am taking the 1 and 3, x and z. So x is x dx by y square z, and this is dz by y square. So when you look at this, it has only x and z, so we don't want y. So luckily y square cancelled, and this z goes this side. So now it is in a nice manner, x dx is equal to z dz. Now if you want to solve this, you have to integrate this, and we'll get a nice equation x square by 2, because integral of x is x square by 2, integral of z is z square by 2 plus c, and then we'll get a nice equation like this, x square minus z square equals to b, right? So this relation we call it as v, right? So now what you have to do now, we have to write the general solution is phi of u comma v. Phi of u comma v is equals to 0. But what is u? U is nothing but this one. Right hand side is a, right? You don't write a, because this is u of x comma y comma z equals to a. So left hand side u of x comma y comma z, in that place x cube by u cube is there, so that we are substituting here. Similarly, v of x comma y comma z equals to b, so there in place of v, x square minus z square is there. So you have to substitute u and v here, then automatically phi of u comma v equals to 0 is the general solution of the given PDE, because that is the working rule is given here. So what is the working rule says, right? Somewhat you have to solve this, and you have to find u of x comma y comma z equals to a, and v of x comma y comma z equals to b. That means some relation between x, y, z, and then some other relation between x, y, z. Then automatically if you write phi of u comma v is equals to 0, it is printed wrongly, it is like this. Phi of u comma v is not here, the parenthesis comes here. Phi of u comma v equals to 0, then this is the required general solution of the given PDE. General solution of the given PDE. So in our problem, right, this is the PDE just now we solved. We take P and Q and R from the equation, and then we group first and second and first and third, and we found u of x comma y comma z as well as v of x comma y comma z in the form of x cube minus y cube as well as x square minus y square, and we substituted here, then that will be the final general solution of the given PDE. Final general solution of the given PDE. So in this manner, right, you can solve a numerous number of problems which is in the form of PP plus QQ equals to R. Right? So, but this is very simple. In most of the problems, times they ask problems on this, right? So try to do at least 1 or 2 problems. So for that I will explain some more examples, because I already told you This is only a trial and error method. Once you write the substitute equation, right, there is no standard procedure is there. You have to use your common sense, right, and you have to try to solve solve, and then you have to find two equations, one with u of x comma y comma z equals to a, another one is v of x comma y comma z equals to b, right? Okay. So now I'll explain one more problem also, right? Then you can understand much better. So here also you can see a problem like p of tan x plus q of tan y equals to tan z. So here also you can see p and q appear only one time, and it appear with power 1, right? So now we take this tan x as your capital P, this tan y as your capital Q, and tan z as capital R. Then we can write directly the substitute equation dx by p, that is dx by tan x, dy by tan y, dz by tan z. Right, now you have to solve this. Here also all looks like same, right? And you are in a nice manner. The dx with tan x is there, dy with tan y, dz by tan z. So directly you can take any two relations and directly you can integrate it. There is no cross multiplication in it because we have a nice a function of x with the dx, a nice a function of y with dy, right? So that straight away you can write like this as, so 1 dx by tan x, you write cot x, cot y, cot z, because 1 by tan x can be written as cot x, right? So 1 by tan x, right? Instead of writing 1 by tan x, they are directly they written it as cot x. So cot x, cot y, cot z. So you take 1 and 2, right? Integral of cot x is log sin x. Similarly, cot y is log sin y. Then they have put log a. Then you may ask, sir, usually they are putting only a arbitrary constant. Why they are putting log of a? A is arbitrary, okay. What is log of a? So this is here, the only thing is, even if you simply put c and you write log sin x minus log sin y equals to a, mathematically is correct. But in order to simplify it, right, they do this type of simple ideas. Because the idea behind this, if a is arbitrary, log a is also arbitrary, right? So that instead of a, they assumed log a, because if a is arbitrary constant, log a is also arbitrary constant. But why they assume like that? Because when you take this log value this side, it is log sin x minus log sin y. So you know log a minus log b is equals to log a by b. I think this you know. So log sin x minus log sin y can be written as log sin x by y. So this is log a, log b minus log b can be written as log a by b. And this side log a as it is. Now remember, logarithm is not a number, it is a operator. I explained this during the offline class, that is day before yesterday, right? What is a log function? Those who are attended the offline classes also, so they know, right? So log is an operator operated on a term sin x and sin y. So when I cancel log x, right, don't think I am cancelling like a number, not like that. If log is applied on sin x by sin y, it is same as log is applied on a. So if log values of both the entries sin x and sin y and a are equal, means the entry should be equal. The idea is, suppose if log a is equals to log b, so this is the idea. If log a is equals to log b, then the conclusion is a equals to b. That only they are using here, right? So log of sin x by sin y is equals to log a. So sin x by sin y equals to a. So instead of writing like this, right? Writing like this is a very nice manner, so that they take this as the relation, and this sin x by sin y you call it as u. This sin x by sin y you call it as u, right? Now whatever you did, right, for x and y, the same thing you can do it for x and z or y and z, because here it is very obvious and very simple, because all the things are looks like same, symmetrical, right? So if you take x and y, you have to write sin x by sin y equals to a. And if you take y and z, you can write sin y by sin z equals to some other same procedure. Procedure is same cot y cot z, same integration, and taking to left hand side and then cancelling the log terms, then you will get the nice relation. So this relation you name it as u, and this relation you name it as v. Then you can write phi of u comma v is equals to 0, where u is nothing but sin x by sin y, and v is nothing but sin y by sin z. Sin y by sin z. Right? So are you able to follow? Hmm?
Yes,
Tell
sir.
me. It's easy only, right? So only thing you should know some basic integration formulas, right? So first two problems very easy, straightforward one. But now we are going to see two more examples for the same Lagranges because it's very important. There you have to use your common sense. You have to do some simplification. Then only you can get U and V, right? Okay. So now we move on. Right. So I think this problem is solved in the class itself, I think, right? So now look at this problem. It is y square p minus xyq equals to x times z minus 2y. So obviously it is in the Lagrange's form, so that is no problem, right? So you can identify p, q and r, and you can write it in the substituted equations like this: dx by p, that is y square, and dy by q, that is minus xy, and dz by r, that is x into z minus 2y, right? So here also, if you take the relation 1 and 2, that is first two equivalents, x and y, right? Here also you have a nice procedure, right? You can take this y square on the other side and x on this other side. So x goes this side, it becomes x dx. And if you take y square on the other side, already one y is there, this one y and this one y cancel. So you will get minus of y dy. So x goes this side, it becomes x dx, and y goes this side, it becomes minus y dy. And if you integrate x, it becomes x square by 2. Integrate y, it becomes y square by 2, but minus sign is there. So this y comes this side, it becomes x square plus square by 2, right? And here they put 2 also here, right? Then you can ask again, sir, you put only a, why you are putting a by 2? So that I'm telling again and again, right? If a is arbitrary, a by 2 is also arbitrary. So according to the problem, we can write the arbitrary constant in a nice manner so that we can cancel out all the constants. We can cancel out all the unnecessary constants, and you can write the equation in a very nice manner: x square plus y square equals to a, and this is nothing but your u, right? But the problem comes only when you find the other relation, right? Suppose if you want to group 1 and 3, right? So you need only x and z, but not y. But here y square is present, here y is present, that is also with z minus 2y. So here eliminating y directly is difficult. Suppose you choose y and z, then you don't want x. So it looks like you can cancel x nicely here. You cancel x nicely here, but still, right, separating the z minus y, taking z one side and 2y other side is not possible, because if they are in product, you can do the cross multiplication. But they are in the difference or summation. In that case, if you take z minus 2y, either it goes this side or this side. So you can't separate z and y, this z and y. So now we have to use our common sense how to do this separation, right? So now you listen carefully. So now whatever I'm going to teach now, it's very simple, but so far you didn't hear about this, right? So first thing what I have to do now, first thing I am multiplying z with dy. Z with dy. See, this is dy. So if I multiply z, the numerator, I have to multiply the same z in the denominator also. Then what will happen? The numerator becomes z dy, that is here. Then what is the denominator? Minus xy. I multiply another z, so that is minus xyz is here. right? So that is one term. So you have to multiply z with dy. Now you can multiply y with dz. Y with dz. So if you multiply y with dz, it is y dz. So it is y dz. And here if you multiply, it becomes x into y into z. So that is xyz. And here minus 2xy square. Minus 2xy square. You may ask, sir, why we are doing like this? Right? Because we try to write or eliminate x as much as possible, and we have to write only y and z. And not only try to write y and z, we have to split y with dy and z with dz, right? So this is only a trial and error method. So there's no formula or procedure is there. You have to use your common sense, right? And you have to do. Then one more thing you may ask, sir, how you add? Okay, these are two are in equivalent, but how you are add the numerator and denominator. But this is very obvious. If as per the right law of number theory, if the any two ratios like this, a by b equal to c by d, then this can be written as a plus c is equals to the ratio a plus c divided by b plus d. Right? So here a is nothing but dy, c is nothing but dz, and your b is nothing but minus xy, and d is nothing but this. Right? So you can multiply anything, numerator, denominator, numerator, denominator. That's no problem, because whatever you multiply in the numerator, the same thing you have to multiply in the denominator. Or whatever multiplying in the left hand side, you have to multiply the same thing in the right hand side. Then automatically it okay. Right? So now, so mathematically, as per the rules of the ratios, we multiplied z with dy and x with dz, and then we are adding both the quotients, and so the numerator will be like this. The numerator is z dy. So here z dy, right? Plus multiply y here, so y dz. So numerator is pakka. Now what is the denominator? Denominator is xyz. Okay. Now if I multiply y here, what will come? Yxz. So xyz. Then yx into 2y. So minus 2x y square. Right? And now you can cancel out this xyz and this xy can. Right? And one more thing you have to write in the numerator, it is something like z dy plus y dz. You just remember, you can come across like this, u v dash plus v u dash. So what is this? U v dash plus v u dash. What is this rule? What is this rule? Integral. Oh, differential. What is this rule? When you get u dv u dash or v u dash, integral or differential? Anybody answer? Hmm? See, when we integrate, right? If two things are in product or both are functions of x, right? And they are in product, then what we do usually? We write u and differentiate v, and we write v and then differentiate u. So u dv minus plus v du divided u dv plus v du. So here it is only in x, so it's not nothing, it's only 1, right? So that u v dash plus v u dash is nothing but differential of u into v, differential of u into v, right? So in place of u, z is there, in place of v, y is there. So z dy plus y dz, right? So keeping one thing and differentiating other thing, then keeping one thing, differentiating other thing is nothing but differentiation of y into z. Differentiation of y into z. So differentiation of y into z can be written as z into dy plus y into dz, right? So after all these things, right, z dy plus y dz can be written as d of yz, d of yz, and this denominator is as it is. Right. Now from this we won't get anything because numerator y and z is there, denominator x and y is there, right? But now what you have to do now, now you take this term and then compare with the first term. What is the first term? First term is dx by y square, dx by y square. So you take the first term dx by y square, that is one relation we have, and then by adding these two relations we get this another relation, that is d of yz by minus 2x plus y square. So even if you add, right, the ratios are same, even if you multiply the ratios are same. So even after multiplying with z here and y is there and adding, but still the ratios are maintained with all the three equivalents, right? So we can equate this with the first equivalent dx by y square, right? Now you can clearly cancel out y square and take this minus 2x on the other side, minus 2x on the other side. So now it looks like minus 2x on the other side, and this side nothing is there. So but in the numerator it is only d of yz, right? So this step is very, very important, right? This step is very, very important. So y square goes here with, it will cancel out. Then this minus 2x goes here, so that it is minus 2x dx. And here once you cancel out, it is only 1. So 1 into d of yz. So that is nothing but d of yz, right? So now we can integrate both the things with respect to x and y, right? So another thing you just looks new to you, right? When we integrate x, it will be x square by 2, that you know, right? So x square by 2, right? But now this is differential of yz, differential of yz. So this is something like dx. It is something like dx, differential of x. So whenever if you integrate a differential of a variable, then your differential and integration will cancel out. Automatically the variable comes out. Similarly here also, when you differentiate yz with d and then you are integrating, means finally you will get the original term, that is yz, right? So when we integrate dyz, automatically this integration symbol and differential symbol cancel out each other because they are conjugate to each other, complement to each other. Whenever if you differentiate some function like x square is 2x, and if integrated, it again go back to the original form. So if you differentiate yz, then if you integrate, means once again you will get the original form yz. So that only they are written here. And then here if you integrate x, it become x square by 2, and then 2 cancel, then only x square is there, right? And in the right hand side you can put some arbitrary constant b, no problem. So here they do on a nice thing, they take this term on the other side and then integrate it. So all these things in a nice manner, right? So here integral of differential of yz is yz, and here 2 times x square, and this is arbitrary constant b, right? So from this you can write what is your u. U is nothing but x square plus y square, right? And but the b is nothing but x square plus yz, right? So this is x square plus y square, that you found by equating 1 and 2. But this x square plus yz you found, right, after doing this step, and then again you might connected this with the first equation, and then you are finding the solution. So here solution procedure is only a trial and error method, right? So you have to use your common sense, and you should know basic integration formulas and integration methods, right, in order to solve this type of problem, not to solve this type of problem, right? Okay. Are you able to understand all these things? Right, before moving on, I will take the oral attendance. Right, so again there is a change in the serial number. So I will show you that. Can you see the screen now? Right?
No, sir.
Can you see? Not. Right. So only up to 36, no problem. Only after that only there is a change. Right. Right. Can you see the screen now?
Yes, sir.
Yes, sir.
Right. So here serial number you can check, right. Up to 36, that is up to Shiva Prakash, there is no change. There is no change up to Shiva Prakash. There is no change. But there are two names are there in 37, 38. That is deleted now, and then previously 39 is Samlarasan. Now Samlarasan is 37. Similarly, Tyagarajan previously 40, now is 38, and similarly Ulaganathan from become from 41 to 39, and the remaining names Jay Prakash on 40, Jeevagan on 41, Jeevanathan 42, Vijay Kumar 43, and Silpi Kuran 44. Right. So kindly note down your new serial numbers. Right. So now we'll take the oral attendance. You tell your attendance properly. So 1 to 10, who are the people present? 1 to 10.
Sir,
6% sir.
1%,
Anid,
sir.
Jonathan
Anid is
4%
1.
sir.
Okay, Anid is 1%. And then 1 to 10. Jonathan.
4%
Number?
sir.
Number 4.
Yes sir.
Jonathan, where you gone? Huh? You attended,
Sir,
then now where you gone?
went out of
After
station sir.
2nd November, you are not attended.
Actually went out of station sir. Just now
But
reached
whatever
home.
it may be, year after you have to attend in a regular manner, right?
Okay sir.
Okay, right. 1 to 10. Any other people from 1 to 10?
Sir, number 6% sir, Shahid Umar.
Number 6, Syed. Okay, number 6, Syed. Okay. Number 11 to 20,
Sir, 13, sir, Smith Kumar present, sir.
13, Smith Kumar.
12 Anand Kumar, sir. 11 Kumar Yuvraj.
11, Kumar Yuvaraj. Then
14 with
Anand
Prakash
Kumar,
Kumar.
14, Ved Prakash. Okay, right.
Number 10,
Number 10, Aman Kumar.
sir.
Okay.
12 Anand Kumar, sir.
12,
Yes, sir. 12.
Sumit Kumar. 12, Sumit Kumar.
12 Anand Kumar, sir.
Huh?
12 Anand Kumar.
Anand Kumar. Number 12,
Yes,
Anand
sir.
Kumar. Okay.
Yes.
And
Number
13, Smith,
13,
sir.
Sumit Kumar. Okay, right. Then anybody from 21 to 30? Anybody from 21 to 30? Nobody. Then 31 to 40. 31 to 40.
So Jay Prakash 40.
What is your name?
Jay Prakash H.
Jaya Prakash H. Okay, Jaya Prakash H. Okay. So now, okay, Jaya Prakash H. Okay. And then, now your new number is, I think it is now 40, right? Okay, what
Yes,
are
sir.
the So 40. Previously it is 42, now it become 40. Okay, it will keep on changing, no problem. So anybody is there?
Sir Shilpi sir.
Shilpi, right? So yesterday only they put your name. So previously it is in 46, now it is in 44, right? So I think Shilpi also, it's only this is the first class, right? For both
Yes,
online
sir.
and offline. But unfortunately, right, Monday will be the examination, right? So at least you can get the notes from your friends, or I already uploaded, right? Are you there in the Google Classroom, Shilpi?
Yes, sir. Yes, sir.
Right? So I already uploaded all the previous classes, video lectures in the Google Classroom. I also uploaded some handwritten notes also, right? But it is not me, right? So I luckily got from the internet, right? But for me, you have to attend my class and you have to take the notes. That is very, very important. But some
Okay.
emergency times, you can refer that notes and you can refer the previous classes videos, right, and try to understand it, right? So that is the
Yes, sir.
only way. Because are you able to attend regular classes? It's not possible. Where you are?
Sir, I'm in Hyderabad, sir.
Hyderabad. So that is again problem, right? Okay,
Yes,
so
sir.
right. So if possible, right, next week after the class, if you have any doubt, you can ask. First, try to read, right? Very simple only, right? You can communicate with your friends also, right? And still, if you have any doubt, you can ask me after the class hours, right? Okay. So is it okay to all of you? All of you give your attendance. So far, I get Anit, then Raghapoth Jonathan, number 4. Number 6 is Syed. Number 10, Aman Kumar. 11, Kumar Yuvaraj. 12, Anand Kumar. 13, Sumit Kumar. 14, Ved Prakash. And then other two members, Jay Prakash and Shilpi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's okay, right? So now we move on, right? Still, remember, class is not over, right? I will take some 5 more minutes and I finish stuff, right? So because you have Monday, you have examination, so I will take only 5 minutes. I finish stuff. Only one more problem I will take, right? It will be a nice one to understand, right? So only this problem we'll discuss and we finish stuff. So here the problem is x into y minus z with p and y into z minus x into q and z into x minus y. So this is the given PDE. So you will get P, Q and R, or all you get directly, and you substitute here, right? So here grouping any two equations is very difficult because for x and y, z is there. For y and z, x is there. So grouping any two equations is not at all possible. So, but one thing you can see here, right? You multiply this term x into y, then you have that minus x into y is here. Similarly here minus zx is there and plus zx is here. Similarly minus xy is here and plus xy is here, right? So what if you multiply these terms x into y minus x is z, similarly y into z minus that is x into y minus xz, that is the first term, right? I will just type it, then it's nice one. This is x into y minus xz. We'll get from the denominator from the first term, and then if you add with the second term, what is the second term? Y into z minus x, so that is yz minus yx, sorry, yx. And then the third term denominator is z into x minus z into y, so plus z into x minus z into y. So if you add all the numerator, then right, fortunately you can cancel out everything. See here, xy cancel, minus xz plus xz cancel, minus zy plus zy cancel. So what it represents, right? If you multiply this term and if you add all this term, the denominator become 0. And numerator you have to add only the numerator, dx plus dy plus dz. So numerator is dx plus dy plus dz, but the denominator, right, if you multiply this term and then if you add with the other terms, equivalent terms, then you get 0 in the denominator. Then people think, oh, denominator is 0, then it becomes equals to infinity. Not like that, right? Here you are only finding the ratio of the differential. So in the differential ratio is 0, means that whenever if you differentiate something, it becomes 0, means the original equation should be equivalent to some constants, right? So that when dx plus dy plus dz is equals to 0 means, right, the ratio 0 means, right, it should be understand that the differential of the term becomes 0. That is the meaning. So dx plus dy plus dz can be written as d of xy plus z, because this is the rule from differentiation. If you want to differentiate any two term, right, dx and dy, you can add that term and you can differentiate uh, either like this or this, but this is not true for multiplication. But in addition, we can do like this, right? So differentiation of x with d, that is dx, plus differentiation of y, right? That is nothing but plus dy, and differentiation of z, right? So don't think here d is common, they are taking out. Here d is not common. D is an operator. Try to understand. D is not a letter. You are taking D letter common. So I have brought a D letter taken outside. Not like that. D is an operator operated on the variable x, variable y, and variable z. But according to the law of differential calculus, right, if the variables are there in the addition, then differentiating separately like dx and dy and dz, then adding all the differential is same as adding all the variables first and then doing the differentiation. Both the things are same. So that since the total differential is 0, they write that same thing like this, right, and then they integrate it. Or otherwise also this things also no need. Directly you integrate from here to here, you can get a nice one. Integral of dx is x, integral of dy is y, integral of dz is z, and if you integrate a constant, you will get a, right? So this is nothing but u. This is nothing but u. So how you got u? By simply adding all this 3 equivalent, then you will get denominator 0 by adding all the denominator. So denominator 0 means don't think it is a number. Only a number 0 means it is infinity. But here the total differential is 0. That means the equation should be equivalent to a constant a. And that equation can be found by integrating the numerator. Right? So that is u. Now how to find v? Right? How to find v? So here all these things are only using common sense. Right? So here they do one more simple idea, right? Not only multiplying with x and y, you just see here minus z is there, here plus z is there, here minus x is there, here plus x is there, here minus y is there, here plus y is there. Now what they are doing? No, they write dx by x as a single term, right? Listen carefully. They write dx by s as a single term, and then dy by y as a single term, and dz by z as a single term, and they consider this as numerator, and they consider this as, these are all things are in the denominator. Now if they add dx by x plus dy by y plus dz by z, then automatically again these terms are cancel out each other, and we are getting zeros in the denominator. So now it looks like 1 by x dx plus, here it is printing mistake, sorry, here, right, 1 by x dx, 1 by y dy, and 1 by z dz. So each ratio, sum of numerators, sum of denominators. So if sum of the denominators, this becomes 0, and numerator is nothing but dx by x, dy by y, dz by z. So the ratios are 0 means the total differential is equals to 0. That means it is equivalent to some constant. So we integrate this. What is integral of 1 by x? Log x. 1 by y, log y. 1 by z is log z. So here instead of, in order to remove that log, they assume that arbitrary constant also log b. So if b is arbitrary, log b is also arbitrary. And here nice thing I already told you, log a plus log b is log a into b. So here log x plus log y plus log z can be written as log of xyz, and right hand side is log b is there. Again, try to understand, they are not cancelling log and log. They are not cancelling. They are saying log of xyz is same as log b. Then according to the logarithms, if log values of two terms are equal, the two terms must be equal. So log of xyz is equals to log b means definitely xyz should be equals to b, right? So from that you will get the second term v. So first term is, right, x plus y plus z. That you get by simply adding dx plus dy plus dz. You will get x plus y plus z equals to a. So this is x plus y plus z, this is u. And then in the second one, again you use your common sense and writing like this. Then you will get xyz equals to b, and that is nothing but your v. So phi of u comma v is nothing but the general solution of the given PDE. Is nothing but the general solution of the given PDE.